totally fine. You can share if you want to. You can also just sit back and let it wash over you and not worry about it. That's fine too.
No, I don't want to guess. I actually figure it out.
Oh, you want to figure it out mathematically? We could, right? Just substitute in Burke's values and then just run from there. We're gonna let the machines do it too. I love Eric. Seriously, I am that. That's why I have the arithmetic page for you guys, because I always wanted to super generalize things. Why? Is it always or is it just most of the time? I'm that guy. But I don't want you guys to be forced to be that guy or that girl. That's why I put the library online for you. It's there if you want it. It's also there to ignore if you want to ignore it. All right, here we go. Let's learn some TI stuff today. Let's do that. Let's see if I can get this zoomed in a little bit. Oh goodness. It's not gonna hold. I can't imagine why my duct tape job isn't working. Oh. There we go. Sweet. Okay. So we're gonna use these a lot in class. I try to use Excel as much as I can outside of class. You got a project on Excel, maybe two now that I think about it. You've got both of your exams are gonna have an Excel component. I'm going to have quizzes that have Excel components. There'll also be a choice. You can use your TIs or Excel in a lot of those places. I don't want to force you to use any one technology. You can also use R. If you're into R, totally fine. I haven't learned it yet myself. You can use PSS, SAS, Minitab, whatever you want. We're kind of like this, too many choices. So in class, I'll tend to use these. And out of class, we'll tend to use Excel that way. It just breaks my heart that they took away your CIS 120 requirement. How many of you guys are just doing the AAOT degree? AAOT? Only a couple of you. There's no longer a CIS requirement on a general AAOT degree. It's gone. Now the specific one, how many of you guys have a specific, you do have to take a CIS class?
I don't think it completely went away because I just had to retake it. Because
that means your degree required it.
Oh.
The general AAOT was stricken. You should have seen Peter when the state did this.
Yeah.
They took it away and he's like, so we're going to send kids out of community college or OUS system without ever taking an Excel class. And the logic was that you guys grow up with handheld technology now. You don't need to learn this stuff in a computer class. Like, are you running Monte Carlo simulations on your cell phone, or are you playing freaking Angry Birds? I mean, there's definitely a difference between what you're doing on your phone and what you're doing mathematically. So I feel remiss in kicking you out of this class without having you crunch some kind of like Excel-based data. So for right now, TI is fine. Oh yeah, hello. Everybody, press the stat button. This is the first of many times we'll press the stat button on your calculator. Yeah. Right there in the middle of your screen. Now, we're going to live our entire lives here in 243. In 244, we'll wander over to here occasionally. But right here, we're going to spend our entire time here. The first thing you got to do is put the data into the machine for it to crunch. Inputs. Press enter for edit. I've got some stuff in mind. Actually, you know what I'm going to do real quick? I'm going to move it over to L6 because I want to save that for 244. Does anybody else have stuff in theirs? Anybody got stuff on their lists? So if you have stuff in your lists, the way to get rid of it is to put your blinker on top of the list name, press clear, and then press down. I'm going to pause here for a moment. On the enrichment page of the website that I mentioned a couple times today, there is also a PDF TI guidebook for statistics. So if you ever need a reference for what we're talking about in class and you don't feel like finding the section of video that it's embedded in, you can always go to that guidebook. It's just statistics. It's not like that annoying guidebook that came with your calculator that has 8 million pages you don't need. It only has the stat stuff. Please.
Are we still going to be doing the quiz in class today?
We probably won't get to it today. We'll do it on Thursday. Yeah, I don't want to rush to get to it, and I'd rather get through this idea and make sure you guys buy this idea before we launch to that. Yeah, we will. I promise next class though. Fair so far? Good. All right. Let's put Ernie's data here and Bert's data here. And I don't care what order you put it in. Ernie had an 81, he had an 80, he had an 83, he had a 79, and I think he had an 82. Order is really irrelevant. Because I'm trying to strip away any of that conditional correlation that we were talking about earlier, Eric. Make it as general as I can. Bert in L2. Now to get from one list to the other, just press the arrow button over. How many of you guys have entered data in these things before, in your previous math lives? Yeah, some of you have. Good, good. If you haven't, I'm taking it back to step one, if it's okay with you guys. Bert is 68, 82, 94, 61, and 100. If you had more Muppets or more Sesame Street characters, you could go L3, L4, L5, Snuffleupagus, Big Bird, Oscar the Grouch. They always seem the smartest to me. Fair? Ish. Now, let's redo Ernie's numbers. We know his average is 81. We know his median is 81. We know his sample standard deviation is 1.6. Let's let the machine calculate all those for us, just to prove a point. So the way, I know, it's thrilling. The way you do that, press the stat button again. And stat button again. Go over to calculate, which is the CALC menu. Just arrow over 1. There's a lot of stuff in here. And then back in the days of mathematical modeling, you may have explored a lot of these, linreg, quadreg, cubic reg, all those things. I'm going to ignore all that stuff in this class and focus just on the very first thing, which is called 1var stats. What do you think that stands for? One variable statistics. What's the variable? What's the variable? What are you looking at? What are you analyzing right now? In particular, right now, we're only analyzing Ernie, right? In list 1, we're only looking at Ernie's numbers. We'll get to Bert in a second. But we're only analyzing one of them at a time. One single variable. In particular, how did he do on his tests? That's the variable. How did he do on his tests? I'm not trying to correlate him to Bert's. That would be 2 variables, right? Bert and Ernie. I just want Ernie. So I'm going to grab Enter. And if you then press Enter again, a lot of stuff shows up. A lot of stuff shows up. Yes, this is good for us, Rachel. This is very good for us, yes?
No, mine doesn't.
This is good for what happened. Oh, if anybody's looks different than this, raise your hand. I will come fix it so it looks the same. The newer 84s have this goofy stat wizard thing. Now you got it. You're good here, Katie.
Yay!
There you go. Is anybody else's, Eric?
And then enter again.
Yeah, let me just shut the stat wizard off. Yeah, just a bug in
Dude,
it.
he's like good while hunting on a computer.
Off. Let's go. Stat calc. There you go, friends. Everybody else okay with their 84s? It's the 84 that might be the issue. But some of the 84s are okay, some of the 84s are not. Okay, let's process all this, shall we? Tell me what you're looking at. It's just a laundry list of stuff. Extract. Go ahead, Rachel, go ahead.
Yeah.
5 tests, n equals 5, good, go ahead. What were your eyes drawn to first?
Well, all of that's what we would need.
Yeah, does this look familiar? That was the X bar that you guys calculated. The average was an 81. Please, Candace, go ahead.
Question, is
Yes.
Excel going to do that same thing for us?
Excel will do any one of these things if you tell it to. So in Excel, you'll go equals average, and it'll pop out 81. You'll go equals stative, and it'll pop out the S value for you. It won't give you the whole ring at once. It'll do it piece by piece. Go ahead, Rachel, ask me that question.
I'm just curious how, if this gives us all the answers and stuff and we do it for the quiz or the test, how do we show the work for this?
What am I more interested in? How you get the number or whether you know what the number means?
Oh,
The DI will never tell you that. It doesn't explain to you what it means. It just tells you, oh look, S is 1.58. There's your sample standard deviation, right? But it doesn't tell you what that means or how to apply it to anything, right? That's why. I don't want this to turn into Math 20 or Math 60 or Math 65 again. I want this to be the next logical step, which is, hey, all these numbers came out, right? That's my biggest problem with a strict algebra class. X equals 2. No, it probably doesn't. Probably equals 2-ish. 2 plus or minus, right, Kelly? 2 plus or minus, right? So what does the plus or minus mean? Let's talk about the plus or minus. That's why it doesn't bother me, Rachel. Because it will never help you with the interpretation. Linda, please, go.
what's the 1.41?
Shall we get into this, yes? Let's get into this piece by piece and talk about which pieces you probably want to remember and which pieces you want to ignore. So this is definitely very important, the average. Because that means you can stop adding things up and dividing by how many there are. Now, for some reason, the TI also gives you this still. Sum of the x's. What is that? 405.
Test scores all out of it.
If you add up all his test scores, you got 405 points out of a total possible, I guess, 500. If you talk about out of 100 points a pop, right? Okay. What's this?
Square.
Yeah, it's the sum of the squared test scores. This is practically useless for us. I mean, honestly, that's point squared. Don't even know why you need it. The TI still, I think I have an idea of why it was important in 1984 when these things were made, but that's okay. This guy right here, we like having this, don't we? Oh, we like having this. We do. We like this because it saves us from having to do that crazy calculation we just did. Check. Love it. What's that? This is Linda's question. That is a lowercase sigma, FYI. That's a lowercase sigma. That's an uppercase sigma. That's capital S, lowercase s. Does anybody recognize that symbol from your previous statistical lives? That's the population standard deviation. Tom, when you asked about dividing by n versus n minus 1, that's what you would get if you divided by 5 instead of divided by 4. So remember, Teresa, you said 2. 10 divided by 5 equals 2. Square root of 2, 1.414. So if this were indeed your population, Tom, that would be the one you're looking at. And we will look at that when we get into probability distributions, because we will have everything then when we're talking about likelihoods. With data, you can't collect everything with data because it's too time and labor intensive. But that's what it is, Linda. To answer your question, very good question, by the way. Everybody fair with that? So if I asked you for a standard deviation and I don't express otherwise, you give me this one. That's the one you enter. They're pretty close, yeah? They're pretty close. But this one is going to be more correct when trying to approximate the population you can't see. If you don't know why, that's why I said it exists on the Richmond page. I encourage you to look at that. Or ignore it, that's fine too. Now, it gets better. It turns off.
But wait, there's more.
There is, look, see that arrow right there? Scroll down.
Oh.
There's more.
There's more.
There is. Yeah, that's what I'm saying, old buddy. It gives you the minimum value of 79. This is a little bit silly because you already knew that because there are only 5 data points. But when you have more than 5 data points, that's actually a lot of help, right? It gives you the max value of 83. Yay. It gives you right in the middle, your middle. It gives you your median for free. No more having to sort data out. I'm going to try to show you as many tricks as I can. If you do the primer quiz for Thursday, I have an Excel video embedded in the quiz that teaches you how to do a mass sort and count of a block of data. It's going to save you a lot of time. On the last primer quiz, how many of you guys went 1, 2, 3, 4, 5? If you watch the video of me solving that, I did the exact same thing. I was like, I'll be right back. I ducked down. I'm like 1, 2, 3, 4, 5. This primer quiz, I show you an Excel shortcut. Because once you've seen how to do it once, I'm not going to torture you with that again. Not at 20. 243. These guys, please don't worry about these yet. These are called quartiles. They're important. I'm not saying they're not important. They just don't measure variation. They measure something else. If you've taken your child or somebody else's child to a pediatrician, those are things you should know how to deal with. If you ever have a doctor talk to you about percentiles or quartiles, that's something you should know about. And I promise we'll get to that. It just doesn't measure variation. It measures, well, we'll get to what it measures momentarily. When I say momentarily, I mean Tuesday of next week, most likely. So, many moments. Fair?
Fair.
That's Ernie in a nutshell. That's Ernie. What does the 1.6 mean again? What does that 1.6 mean again?
Distance
That will be the
average.
Ah, I like it. You have to use the word average twice when you interpret it, don't you? Just like you did, right? You said. You did. You got to use the word average twice. It's the average distance of the data from the mean. So you have to, there's 2 different averages. There's the average of the distances, and it's the distances from the average. So you have to use that word twice in order to be 100% correct about the interpretation. Fair enough?
Yep.
Average distance the data is from the mean. That's the way I want you to think about it. That's what the TI won't give you, Rachel. It will give you the number. Yay! Because this is annoying. But the interpretation you have to know. And I know you do. Go.
I'm sorry, what's
No, don't be sorry.
Okay. The bar or the X, what is that?
X bar. That's
X bar.
what is that? What's the X bar again?
Average.
Which average?
The mean.
Which mean? No, it's not the population, is it? It's a sample, right? It's a sample average. What would the, anybody remember? I mentioned it once or twice. What the population means symbol is. Do you remember this? Think of a tiny kitten. Mew. It's mu.
Oh.
The Greek letter mu. It is. We'll come back and talk about that on Thursday again. I don't talk about it much. Why? Because you're not often going to have it, are you? You aren't often going to have mu. You're going to have X bar because you have a sample. Does that make sense? Hope that makes sense. Okay. How about Bert? How about Bert? Right? What's Bert's sample standard deviation? Has anybody calculated it yet? Maybe. Good. Tell me why maybe.
16.6.
Oh, how'd you guys get that? Walk me through it. If I want to get, I have Bert's data in L2, right? Walk me through. Teresa, walk me through. What do I press? I'm on the phone talking to you and I'm doing my homework.
Well, I didn't do it on the calculator.
Oh, you didn't? You actually did it out?
Yeah.
Oh, that's awesome.
Without the.
Yeah, I mean, she just basically redid what we did with Ernie. That's fantastic. Teresa, I don't want to do that. Like, I'm like making
So
dinner.
I was trying to
My
do
kid's
it on
screaming.
the calculator, and I put, well, with the, I mean, it's in the calculator.
Yes.
But I went to stat, and then I went to calc.
Stat, okay, so stat, calc.
And I went down to the 2 variable stats.
Avoid that. You can do it from 1 or 2, but let's do it just in 1 because I want to train you guys only to go to 1 var stats if that's okay. I love what you did because you went to 2 and it probably gave it to you in there. But I want to keep you out of that because that also gives you correlation coefficients I don't want to get messed with. I know it. So let's go to 1 var stats. So now I'm here. But Teresa, if I just press enter right now, I get Ernie's numbers again, right? So how can I tell the TI to look at Bert's? And this is a little bit counterintuitive. You have to tell it to by pressing second 2. You see what that does? It puts an L2 after 1 var stats.
Second 2 what, Rick?
Second 2 for now. And if you don't do that, where does it assume your data is? In list 1. So if your data is in list 1, this is unnecessary. You don't have to put 1 var stats L1. But if your data is somewhere else, you have to tell it it's in list 2. Now press enter. Get this out of the way so you can see it. All right, what do you notice? What do you notice? Why is the average and the sum of x the same? Because they have the same total points, don't they? They had the same total points. It's just how they got them was different. Bernie again. Ernie was more consistent. Bert was more buckshot scattered. But the sum total points of 405 was the same for both of them. This is definitely different, isn't it? Sum of x squared, that's definitely different than it was. And then you really start getting the differences down here. There's your 16.6 you got, Teresa. What I find awesome, Eric, your first measure that started this whole mess, successive differences, we determined that at that measure, Bert was 10 times more variant than Ernie. And look what just happened. Bert is 10 times more variant than Ernie. Isn't that kind of cool? He's 10 times, whether you use sample standard deviation, whether you use the population standard deviation, whether you use the E deviation, 10 times more variant. And there are other methods too that might not be exactly 10, but I just find it awesome that what you guys often come up with is damn close. Hey, something you guys didn't mention today was the overall range of the values. Ernie's were only from 79 to 83, that's a distance of 4. Bert's are from 61 to 100, that's a distance of just about 40. 10 to 1. I mean, I find it just fascinating that they often come down to that same thing. Whether you're talking about the overall range or the average range, oh, so cool, so cool. It's like math in action, I love that. Ask me that question. Just moving. Sorry, I thought I saw a hand. I'm like an amphibian, I see motion. Down, lower. There's your median and your high and your low. Beautiful. Later we'll learn how to pull these as variables and use them. Later, not right now. You guys are ready to be done, I think. It's a good time to be done. Yes. So what is the big picture from today? Wrap up today in 2 or 3 sentences for me. Why did we come in here today?
Measures of consistency.
Yes. And what was the one we decided to use for a consistent measure? Wait a minute. Why do we need them? Why do I care? Why couldn't we have stayed home today and drank coffee and just relaxed and taken a nap?
For sample deviation.
Why do we care? Why is it important? I'm not picking just on Candace either. Anybody else can jump in too. Why do I want to measure this consistency versus inconsistency?
Giant
Accurate.
Oh, good. We're always going to have a sample. So I need a snapshot of the population through the sample. Why can't I just ignore variability?
To be more accurate in our findings or in our
Yeah, accuracy and precision. This is actually a little bit of both. You can have 2 samples that are exactly the same accuracy-wise, which would be center-wise, but that are very different precise or precision-wise, yeah? Very different precision-wise. Good, good, good. And, oh, Teresa, go, please.
Maybe in those graphs that you showed us, or the statistics that showed the plus or minus, it will show that there's a wider spread.
If the variation is higher or lower. If it's higher, good, good. Yes, nice connection. And if you look at the extra resources for this, which I don't expect you to do yet, you'll actually see another mention of margin of error in there, because standard deviation is locked right into that margin of error idea. The smaller a sample, that you draw, the larger the margin of error it has to be. Now, hopefully that would make sense mathematically. Because in this quantity right here, as this number gets smaller, if this stays the same, as this number gets smaller, this whole thing has to get bigger. As this number gets bigger, the whole thing has to get smaller. Inversely proportional, right? Dividing by a larger number makes a smaller number overall. Margins of error reflect that in the Gallup polls. Very nice connection. Very nice connection. What's the one measure we're going to talk about for variation? Very nice. Standard deviation. Which is a measure of what? Give me a little more than average of average. Just a teeny bit more. Average distance.
Average distance from the average.
Good. Average distance of what from the average? Yeah. That's everything I need and nothing more. It's the average distance the data is from its mean. That's it. You don't have to say anything else than that. But you do have to say that. You have to have all those ideas in there. Fair? Bring that back with you on Thursday. We'll put it to work. Because now you're going to come back Thursday going, I forgot it all. That's okay. Say it one more time. Somebody say it out loud as they're walking out of the room. What is standard deviation?
On average.
On average,
Data will be
S units
points away from X bar.
from X bar.
Okay.
Yeah. Okay. That's perfect. Perfectly said. Perfectly said. They are. That's okay. We'll get the videos up for you.
So basically the average is
Absolutely. Do that. Yeah, do that. For sure. For sure. On Tuesday, that's fine. Tuesday. Whatever's easier for you.
Thank you.
Go for it. Take this with you. Bring it back on Thursday or Tuesday if you want. Once again, since it meets two sides.
When I
Cool.
get done, I'm going to send you a picture of what I
Got it.
I'm going to ask you.
Hi.
Hi.